I've prepared the base solution for assignment 2. I'm going to show you what's the same and what's different between assignment 2 and assignment 1. And I hope you follow along because I haven't put all the arrows in and the annotations in the hope of keeping things less cluttered. We have our servers, we have our game threads, we have our clients. We still have our game database, and we have our word database. The word database before was synchronized. Here I've taken the synchronized word out. We have a new thread over here, and that thread is called merger, and it is sharing through the buffer manager. It is sharing a number of buffers with the game threads. Each one of the threads is accessing a different buffer. I have separated the word database into a word list and an actual word database. Inside of here is the collection of responses associated with words. Here is a word list all the game servers are accessing together. This is read-only, so there is no need to synchronize. This is only accessed by the merger, so there is no need to synchronize. And these buffers here, represent an array full of buffers. Each one of these buffers is not synchronized, and the contention on them is resolved using double buffering. Okay? So this is supposed to be double buffered. You're going to have to implement a double buffered pattern on side of here. This message queue is associated with this tag here. We have talked about threaded servers. We are now going to be doing a pre-threaded server. And a pre-threaded server means that these game threads are created ahead of time. When client 1 comes in and asks to join a game and there's no games at all, the server does not spawn, does not instantiate a game thread. Instead, what it does is it signals to the next waiting idle game thread that there's a client that needs servicing. In response to a client coming in, the game server is going to signal to the waiting threads, and the next waiting thread on the queue is going to grab the message, and the message is going to be the socket of the client. Okay, so this message queue, the message in the message queue is the socket of the new client wanting to join a game. These arrows here represent game 1 and game 2 blocking and waiting for a job, essentially. So this is a dispatching of a job, the job being the client socket, and this is waiting for and receiving a job. Just like in assignment 1, you're going to have a little array of the clients with which each game thread is playing with, essentially, but it's going to be getting them through a message queue. To summarize, what my intention here is, you're going to have synchronized. This represents a mutex, and we have the same kind of interference between the server and the game threads about adding games and removing games. This is going to be our mutex. Over here, you're going to implement a signal wait message queue. And down here, you're going to implement a double buffered. And instead of just double buffer, because we have multiple threads, the double buffer becomes a multiple buffer. But the idea is the same. So you'll notice here is that I've got 2 game threads plus a consumer thread. So these are 2 producers, and this is 1 consumer. So the total of the buffers is the number of producers plus the number of consumers. So that's 2 plus 1. In the broad sense, I would encourage you to say that there could be multiple consumers. So we could have more than 1 merger, in which case, if we had 2 mergers and 2 games, that would mean that we would need 4 buffers. You're going to have to use wait notify in order to get the next available buffer. Okay, so you have to take the double buffered logic that you were doing in the lab, and you have to extend it to handle multiple buffers. In general, I'm hoping that you can reuse the code from assignment 1, even if your solution is slightly different. I want you to take what you did in assignment 1 and migrate it such that you have a mutex. This is my goal. You have a mutex, you have a message queue, and you have multiple double buffering. Those are the criteria inside of assignment 2. You are allowed to reuse your solution for assignment 1. You don't have to go and redo it just to make it match exactly, as long as you have a mutex, a message queue, and a double buffered extended to multiple buffers. Just a tip for what we're going to do in assignment 3. The reason why I've separated out the word list, which is the guesses, and I've separated it into a read-only list here, and the responses are being put into here. I've separated out read-only versus writing, is that in assignment 3 we're going to add another thread. While the games are going to be reading words, this guy will be allowed to occasionally add a new word to the list, and we will develop a readers writers problem, and for assignment 3 you'll be doing the readers writers solution. Okay, so that's where we are going for assignment 3. Thanks.